Welcome to Spring Lib.
In this question, we have given a almirah which is supported by two hinges, and these hinges are situated at a distance of 1 feet from the end. Now it is given that magnitude of these forces exerted by the hinges are equal, and we have to find this magnitude. So first of all, I am going to draw the diagram for this given figure. This is our almirah, and it is supported by two hinges. Let there is one hinge and one hinge is let which is here. Now I am going to show the forces which will act in this system. One is the weight of this almirah that is acting vertically downward, that is 8g. One is the normal force at let this point is A and this point is B. One is the normal force that is N1, and here one is the frictional force, let this will be F1. One is the normal force acting at this hinge, let it will be N2, and one will be the frictional force that is F2. It is given in the question that the magnitude of the forces exerted by the hinges on the door are equal. So therefore, resultant of N1 and F1 at point A will be equal to resultant of forces that is N2 and F2 at point B. Now equate this to, so this is under root of N1 square plus F1 square, and this will be under root of N2 square plus F2 square. Let this is our equation first. Now the system is in translational equilibrium. So we can say that net force in horizontal direction, that is 0. So from here we get N1 is equals to N2, and net force in vertical direction also 0. So from here we get 8g is equals to F1 plus F2. Now put the value in of now put these two values in equation 1. So putting the value in equation 1, we get F1 is equals to F2, or I can say 2F1 is equals to 8g. From here we get F1, that is 40 Newton. Now let us take the torque about point V. So torque about point V is given by N1 into 4 is equals to 8g into 0.75. So from here we get the value of N1, that is 15 Newton. So now we have both the value N1 and F1. F1 we had calculated, that is 40 Newton. Now put this value in equation 1. So from equation 1 we get the force exerted by the hinges, that is under root of F1 square plus N1 square. This is the resultant force at hinge A. This will equals to force at hinge B, that is F2 square plus N2 square. Both will be equal, and this will come out 42.72 Newton, or I can say 43 Newton. So this is the answer for given question. Thank you.